I guess we can start now. Okay, as I first welcome you all to the new semester and the new subject, and thanks to your interest shown for this selective. Title of the course, as you know, is Hypersonic Flow Theory, 15 AES442. Today's session will just dedicate for understanding about the course and the plan for delivery. So we will not get into the topic as such today. Tomorrow onwards, we'll get into the actual syllabus, the portions. Okay, first about the course objective. The objective of the course is listed as the one to enable students to appreciate the differences and commonalities between supersonic and hypersonic flows, to introduce basic physics of hypersonic flow and their applications in space shuttles, atmospheric re-entries, scramjet engines, and other practical situations, and also to understand and apply approximate and exact methods in hypersonic flow theory. In fact, the last point, that is understanding and applying approximate and exact methods in hypersonic flow theory, that spans over the entire course. So even the points that were listed above, that is to introduce basic physics of hypersonic flow, etc., they are all done in tandem with or in parallel with understanding and applying approximate and exact methods in hypersonic flow theory. So what are the tools used or how they are formulated in hypersonic flow for analysis is what is being primarily focused in this particular course. I'm not listing the entire syllabus here, just to give you a brief overview of the 3 units, Unit 1, Unit 2, and Unit 3. Unit 1 is primarily introduction to hypersonic flow and flight paths and the various regimes. And the Unit 2, actually, the way that I have written here is the way it is given in the syllabus. In fact, the way that we address in the class will be there will be a lot of overlap between unit 1 and Unit 2 in particular. For example, in visit analysis, we will start that in Unit 1 and will continue that in Unit 2. Anyway, that is going to be the second part. And the third part is primarily study of method of characteristics and blunt body flow problems, flow, heat transfer, viscous flow and heat transfer in hypersonic flow. So this is roughly the division of the major topics. In the slides, I have given the complete syllabus, which you can go through at your leisure when after I share this on MS Teams. So course outcomes. Course outcomes, as you know by now, what are students supposed to accomplish by attending this course? So from the student's perspective, what he or she will be capable of doing after undergoing this course successfully is what is usually listed as a course outcomes. So CO1 is identifying critical flow physics and phenomena influencing hypersonic and planetary re-entry flows. CO2 should be able to explain the recent developments in the analysis of hypersonic flows. CO3, be able to apply, say, shock expansion theory, various approaches, surface inclination method, Newton's theory, etc., for the estimation of pressure distribution on simple shapes. These are applications of these are formulations of fundamental analysis methods for hypersonic flows. CO4 is formulation and solving of problems involving inviscid hypersonic flow over blunt bodies. And CO5 is the study of viscous effects and being able to analyze and identify viscous effects in hypersonic flow applications. So this is how the 5 outcomes of the course are laid out: CO1, CO2, CO3, CO4, CO5. This is how they are laid out. Now, to give an overview of the course content, the the plan that we will follow in the course would be, first we will have a brief introduction to hypersonic flight, the various phenomena that are associated with hypersonic flight, basically features which are unique for hypersonic flows and their applications. And then we will look at the various analysis methods for hypersonic flow, assuming inviscid models, or with the assumption of inviscid flow. Now, inviscid flow, as we will soon see, has a lot of importance in hypersonic flow applications, because many of the pertinent physics can be captured, or at least we can get better insight to the problem by inviscid formulations. So inviscid formulations are important, particularly in hypersonic flows. And we will also briefly discuss about the method of characteristics as applied to hypersonic flows. And we will look at the effect of viscosity, because in the initial parts we are constrained to inviscid approach, and later we will also look at what is going to be the main impact of viscosity and heat transfer. So I have not listed it here. Viscosity as well as heat transfer in hypersonic flows. Textbook, John D. Anderson's hypersonic and high temperature gas dynamics is a good textbook. Actually, it's yeah, that is listed as a textbook, and it's a fairly good treatment of hypersonic flow, the various methods of formulations and their applicability, their disadvantages, shortcomings, and strengths, etc. So it's a good textbook. And there are other textbooks. You don't have too many books actually in hypersonic flow, being somewhat focused domain, as not unlike a general domain. You don't have too many books, but then there are several reading materials, and I will also be making use of journal articles, papers, etc. in the course, while covering the topics of the course. So what we have listed here are the textbooks which are listed in the syllabus. Fletcher's Fundamentals of Hypersonic Aerodynamics is also a good one. Now, mode of delivery, as we know, is going to be online sessions until there is any dramatic improvement in the COVID situation. So, for what we can see now, most part of this current semester is going to continue online mode. Then, obviously, we'll follow the presentations and MS team sessions for the lectures. And short quizzes will be there after a series of sessions. That's not every session, but then after a series. So when a particular topic is covered, I usually used to have as a follow-up online quiz. So which means that for each module, you are likely to have multiple quizzes. And there is an interactive session, as you know, which is reserved for Saturdays, or Saturday sessions are reserved for QA. So though they are optional, whenever you have any questions or doubts or anything to be clarified, or anything related to be discussed about the course, we can make use of that slot. Now, performance evaluation. Yeah, what I understand now is that it's a 50-50 split, and the end semester is 50%, whereas the internal assessment will consist of quizzes, assignments, and midterm exams. Apparently, there is not going to be P1, P2. This is what I just heard from the students. So some of you only told me this morning who attended everything in this course. Otherwise, I was under the impression of P1, P2, but apparently there is an announcement which I am yet to see. So once that is formalized, or once we get that information, I will confirm this. So if so, there is going to be a midterm exam plus other constituent components like quizzes, assignments, etc., which will make the 50%. And the next 50% will be end semester evaluation. Now, when I say quizzes and assignments, I would quizzes will usually follow the normal pattern, but assignments I would try to make at least some of them as presentations by you on given problems, which may have a bit of a design flavor or analysis flavor, where you extend whatever has been discussed in the class to specific situations or specific analysis or specific applications. And I would probably make a few teams where you can do the presentation, and the evaluation will be based on the presentation. So that will be, I mean, we cannot have too many of them because of time constraints, but wherever it's possible, I would like to assign such tasks which will be more like presentation kind of submission. Okay, now for each class, as we know, the MS Team sessions will take some time. I would try to restrict it to 15-20 minutes. What I have here is a pie chart, an exploded view of a pie chart, which is something like a rough time division that I have in mind. Now, there will be variations from time to time, etc., but this is what I roughly target for. I want to constrain my talk to 15-20 minutes because of the attention span in the online sessions. It's globally suggested that it should not exceed. A person talking should not take more than 15-20 minutes, because after that, students are likely to lose, very likely to lose their attention. So this is what I keep as a guideline for myself, but I see myself wavering from that quite often because of two reasons. One is overall syllabus pressure, of course. We need to finish the portions as much as possible within the stipulated hours. Second is, when there are lengthy derivations or equations to be completed or analysis to be completed, etc., it becomes ineffective or inconvenient to split it across sessions. So one would try to finish it as much as possible in a given session. So those things usually stretch the targeted 15 minutes to longer periods, which I will try to minimize that, but then often I see that I exceed that 15 minutes. So 15 to 20 minutes I anyway keep as a target for myself. Now, what do we do after that? Yes, QA sessions. That is in addition to whatever that optional session on Saturdays. I strongly encourage that after each session, if there is anything that is not clear to you, it may be ambiguity, it may be a doubt, or it may be lack of explanation provided by me, or it may be even mistakes which were mentioned by me. You can take them up all in the QA sessions. And needless to say, the discussion should not be reserved or delayed till QA sessions. Whenever you see anything that is not clear, even when I am talking, whenever you see anything that is not clear or is ambiguous or wrong or a mistake or a slip of tongue, anything, you can and you are requested to stop me and raise your doubts or concerns or suggestions. So please keep that in mind. Anytime during the talk, you can stop me to raise a doubt or a concern or a question or a correction. So, but then this only thing, remember to unmute yourself before you speak. So otherwise, what I mean by the QA session is the one after each class, each talk. We can have some minutes dedicated only for discussion. So whenever you have any doubts after the session, you can raise them also. And numerical problems. That is, we will have a few sessions where we'll attempt numerical problems. What I would suggest is that as I explain the problem or as I try to work it out on the live on the screen, I would request you also to be parallelly doing that, because unless you work on it, you won't get a feel for the solution of the problem. So solving of the numerical problems are actually to be expected to be done by you and just guided by me. But I will be presenting all the steps, and most cases I'll be presenting the results also. But I request you to be parallelly working it out, so that if there is any lack of clarity in what I am saying, it can be cleared also at that point of time. And also you become more confident about working out problems. Quizzes, as I mentioned, will be there time to time. And whenever anything that has to be presented by you, we will make use of part of this 50-minute session for your presentations also. So, and also some videos, which I think I have not listed here, but I have it here. Yeah, in the pie chart, I have it. I have listed some video which are actually available in YouTube. Some of them you may have even seen also. But from time to time, to explain some of the concepts or their applications, I'll be making use of videos. These videos will not be lecture videos. Lecture I can give myself, but then the graphic demonstrations of them, either with actual videos of applications, etc. That's where I require online resources. So I have made a collection of them, and depending on the topic that we are talking about, if there are useful videos which can give us a better insight to the real application of them, I'll be making use of them also. So that's what I mean by videos in the timeshare pattern, timeshare model. So this is roughly how I would envisage utilizing this 50 minutes of each session. Again, emphasis would be to restrict my talk not exceeding a reasonable time limit, so that we will try to make it as interactive as possible. But then that interactive part of it comes only from your side. I cannot do much about it other than stopping and asking you to raise questions, queries, etc. So unless there are questions or these ones from your side, we cannot make it interactive anymore. So please keep that in mind. So this is the time division that I have in mind. Syllabus, I'm not going to read it out anyway. We are going to go through all that, and for your interest, you can go through the syllabus, etc. And the platform, though I didn't mention here, all the materials that I present here, I'll be uploading in MS Teams. Many times I'll upload it on the same day, or in some cases, a few sessions will be required to complete a part. So if so, after that session is complete, or that is after so many sessions are complete, I will upload the total material. That is, if one particular topic requires multiple sessions to cover, after all those sessions are, after that particular topic is completed, I will upload the presentation on the on MS Teams, so that you can subsequently use it. So this is roughly how I would like to proceed through the course. I guess I'll stop it here. Yeah, so already I have, it's about 15 minutes, I think, since I started talking. So for now, I'll stop here. You please unmute, and if you have any questions or concerns or also suggestions, just take all this. Whatever I say are from my side. Okay. So I may have some reasons for putting it this way. I may have some reasons for arguments for splitting the time like this. But you have all the right to correct me, or raise your suggestions, or give your suggestions, or raise your concerns. So please let me know if anything has to be changed, or also if you have any questions or any further clarifications required. I stop here. You may please unmute and talk. I guess we have a class tomorrow. So what I would actually start off with is talking about hypersonic flows as such. What do we mean by? It's not that you don't know about it. You know, you all know what is hypersonic flow, but I'll try to formally place it from the theoretical as well as application perspective. So that will be my aim tomorrow. Before we start talking about analysis and other things, we'll try to place hypersonic flows from the perspective of what is categorized and why it is categorized, and what are some of the applications. So that will be the focus of what we discuss tomorrow, next class.
Okay, sir.
Yeah. Anything else that you want to ask or suggest? This course, as the name indicates, it says hypersonic flow theory. So it deals with a lot of formulations and analysis that pertain to hypersonic flows. But I'll be making conscious efforts from time to time to relate that theory to actual application. So wherever it's possible, I'll try to highlight the application of it, and we may attempt to also solve problems as which are very close to the applications of each topic. Anything that you want to suggest or check with me about the overall whatever we have discussed now? I mean, suggest in the sense, even if you are not confident about what you are going to suggest, that's okay. You can just raise it. Maybe you have a point. If you have a point, then let's discuss it and take it. So what I'm saying is, don't shy away because you are not sure about what you are going to say. So any suggestions from that, because it's online mode is actually new to all of us. So we are actually, it's just over a year now we are using this. And from the student perspective, I have absolutely no idea how miserable it will be for you. I know I've heard some feedback, but then if there is anything that you feel you can suggest to minimize or reduce that misery, you're most welcome to suggest that. If it is practical and if it is viable, I will be happy to implement it also. And this is not the only window of opportunity. Anytime that you feel you want to raise something, you can do that. I mean, so I'm just asking now because it's the beginning of the course, but anytime during the course, if you feel that something has to be changed or corrected, etc., you can let me know anytime. Okay, if you don't have any questions, then we can stop here today and then continue with the sessions tomorrow. Anything? Yeah.
No, sir. No, sir.
No, sir.
Okay then. Okay then. Thank you. Thanks a lot to all of you for joining. And
Thank you,
in
sir.
fact, any point
Thank you.
of time, the overview that I've given about the course and delivery, etc. If you have anything to suggest about it or to make changes, you may please let me know. I cannot probably change the syllabus, but anything about the delivery, the mode, the time sharing, and stuff like that.
Okay, sir.
Okay. Thanks to all of you. Thanks to all of you.
Thank you, sir.
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 Thank you.
Thanks, sir.